In this tutorial, you will learn to use NX 7.5's motion simulation module to emulate the motion of gears. Download the zip file at the bottom of the page and open up the gears part file. Click Start Motion Simulation. In the Motion Navigator, right-click Gears and select New Simulation. In the Environment dialog box, make sure that Component-Based Simulation is checked. This will convert components of the assembly into links and assembly constraints into joints. We're not going to need the slider joint that NX created, so we're going to delete it right off the bat. NX would also like to know if we would like to ground any of the links. The answer is no, because we want them both to move. The gear coupler can be found here. As you can see, the prerequisites for a gear coupler are two revolute joints. So before we can define a gear, we'll need to define the two joints. Click on the joints icon right here. The action link for the first revolute joint will be the link named gear. To specify the origin and orientation correctly, use some smart clicking. Click on the interior edge as shown here, and NX will automatically select the origin correctly. When asked to specify the orientation, click the same edge and it will give you an appropriate normal vector. We're going to want these gears to move, so click on the driver tab and change rotation from none to constant. Give the system an initial velocity of, say, 50 inches per second and click Apply. With one revolute joint defined, we can now define the second. Again, using smart clicking, select the interior edge and NX will automatically specify the origin and orientation. With the revolute joints correctly defined, we're now ready to define the gear coupler. Click on the gear icon again, and now select the first and second joints in order. The critical piece of information in the gear dialog box is ratio. What you would like to enter here is the ratio of one gear's radius to the other. Now, we have expressions in each of the gear part files for the radius, more specifically the diameter, but we're going to need to add a slight perturbation term for the size of these teeth. As it turns out, that term is 0.025 inches. So we're going to add that to the quantity diameter of gear divided by 2. That's the radius. And our second radius will be 0.025 plus diameter of gear 2. Click OK. As you can see, NX has indicated the gear coupler with these tan circles and this arrow. It indicates the direction of motion. You zoom in, you can see that they look like they're right about in the center of these teeth, so everything should be in place. We now have all the ingredients necessary to create an animation. Right-click on Motion 1 in the Motion Navigator and select New Solution. Gravity is going to be unimportant in this simulation, so just set the gravitational constant to 0. Make sure that the Solve with OK box is checked. NX is now solving the system, and soon we'll have an animation ready to watch. Current progress status is at 100%, so we now have an animation. As you can see, the gears appear to be moving in tandem, and if you zoom in on the teeth, you can see that they do in fact line up, so our gear radius ratio is correct. I hope that you've enjoyed this tutorial. Thanks for watching.